What do you think of when you hear Florida? Well, maybe a lot of things, but let's focus on the good stuff. Some things that come to mind might be Disney World, or palm trees, or the Florida Keys, manatees. I think of those things as well, but I also think about the coastal wetlands of Florida quite a bit. I've witnessed amazing things in the marshlands and mangrove ecosystems of Florida, from tiny little mangrove crabs creeping around to beautiful pink roseate spoonbills flying through the sky, and even some strange noises that I can't really put my finger on. But it isn't all fine and dandy in the Sunshine State. Rising sea levels pose a threat to coastal areas around the globe. One of the most vulnerable areas in the United States is the state of Florida. The coastal wetlands of Florida provide a buffering zone of protection for communities against sea level rise and flooding. And this is because these coastal wetlands have plants that can break up the energy from storm surges. And also, they can build soil over a long period of time. In addition to these protective services, they also provide a biodiverse habitat for reptiles, birds, mammals, and other plants. We decided to investigate wetland loss to date along a section of the Intracoastal Waterway. This is essentially a water highway that goes along the coast of Florida, and it's for boats so they can do commerce and recreation things. Using imagery from satellites that orbit and photograph the Earth and mapping tools, we've been able to examine this coastal loss. We did this over a 6-year time period. And we looked at satellite imagery from 2 time points, 2018 and 2024. Once we have our imagery, we can then train a machine learning algorithm to distinguish the different land categories present in the wetlands. This map symbolizes mangroves, marshlands, open water, and developed areas. Once the map is created for the 2 time points, we can then run something called a change detection analysis, which can essentially look at the pixels and tell us how it's changed. So far, we found that a section of the Matanzas River has had a collective 2 to 2.5% loss of mangrove and marshlands. The implications of this can provide us with insight into the rate of coastal wetland decline. Some implementations, such as reducing boat wakes and strategized plantings, can help reduce the coastal wetland loss. With careful monitoring, planning, and action by community stakeholders, we can continue to allow these ecosystems to thrive, and humans, animals, and plants alike can continue to use them. Thank you.
Thank you so much for that wonderful presentation, Aaron. Question for you.
Yeah.
Have the recent storms had a significant impact on the wetlands?
Yeah, so storms can cause storm surges, which then can lead to increased rates of erosion. I personally haven't looked into it too much myself, but I would say that with the knowledge I have, they definitely impact the coastline.
And it seems like the storms are just getting stronger and stronger, so those impacts could increase. Again, this is very important work, and I appreciate your efforts in this area. Are there good questions from the audience for Aaron? Yes, right here.
So I know, hello Aaron, do you know why?
Hi, Phil.
In our lab meetings, we talk about boat wake stuff. I don't know, I think we discussed you like looking at areas where you might see higher boat traffic.
Yeah.
I don't know if you've looked into that, but would you suspect if you were to superimpose some kind of analysis on that, that you would see a higher rate of erosion around areas with those higher boat wake traffics compared to more calmer portions of the intercoastal?
Yeah, I mean, that definitely makes sense. I think it's kind of a 2-factor thing. So areas where yachts are zipping through quicker may have more erosion, but it also depends on just the hydrology of that section of the Intracoastal Waterway as well, kind of how it's shaped, how the river flows in that section. So I think, yeah, I don't know if that answered it, but.
Okay. Question right here.
Kind of along the lines of Phil's question, is there any way to quantify how much of the percent change over the 6 years has been due to like anthropogenic sources or causes as opposed to like stochastic or random factors?
Yeah, so it's difficult to parse out with this analysis. All I'm really looking at is kind of observational stuff, what has turned into open water, to actually parse out like what's causing these specific erosion events would require probably an experiment of some kind if I had to guess.
I have a question for you. Would storms be anthropogenic or stochastic?
That's a good, I guess, yeah, there's the argument that they would be anthropogenically caused because of climate change, but traditionally they are like stochastic because we can't actually predict when they happen. So,
Yeah.
yeah,
Okay.
that's a good question.
Other good questions? Yes, right here.
What brought you the most joy for doing this project?
Actually getting a model that looked decent. So like I went through like 40 iterations of this map that just looked terrible because with machine learning algorithms, if your factors aren't really dialed in super accurately, they just go haywire. So actually getting something that makes sense and then referencing it to real imagery and it looks matched up is very satisfying.
Fantastic. Thank you so much, Aaron.